Hello and welcome to another video on orbital mechanics. I'm going through the book Orbital Mechanics for Engineering Students by Howard D. Curtis, 4th edition, and I'm up to problem 3.4. You can see it on the left. And problem 3.4 states that in terms of the eccentricity E, the period t, and the angles theta and beta in radians, find the time t required to fly from point 1 to point 2 on the ellipse. C is the center of the ellipse. Now this looks like a really difficult question, but it's actually really trivial. We have the formula for the mean anomaly, M E equals eccentric orbit minus E sine the eccentric orbit. And we can use that twice. We can use it once for point 1 and once for point 2. And ME equals 2 pi over t. So we'll put that in as well. And we know that t is different in each case. So we have 2 pi over t times t1 equals alpha minus E sine alpha, and then we have 2 pi over t t2 equals beta minus E sine beta, and all we do is we just subtract 2 minus 1 to get the time from 1 to 2, so that becomes 2 pi over t2 minus 2 pi over t big T t1 2 equals beta minus alpha minus E sine beta plus E sine alpha. Now that's very close to the answer. So the t that we're looking for is, so we'll take 2 pi over t out, so t2 minus t1 equals still that, and that is t2 minus t1 is what we're looking for, so that is t. So we've got t equals t over 2 pi upon the rest of that. Now you'll notice that is still not what we have in the answer, but it is a valid answer, but they've given a different answer. So to get to what they have, there is an identity that you can find on Wikipedia. So sine P plus sine Q equals basically 2 sine P plus Q over 2 cos P minus Q over 2. So we can use that. Now we have slightly different signs, and that makes it a little bit of a problem, I think, because we have a minus sign beta, but we can deal with that. We can do t equals t over 2 pi minus alpha plus E sine minus beta plus E sine alpha, and then we're gonna just use the negative sign to sort it out, so that becomes t over 2 pi beta minus alpha and that becomes plus 2 sine alpha minus beta They've got a -2 on theirs, but I'm pretty sure it's exactly the same. In the end, like, so 2e over 2 cos it is and then we have minus beta minus alpha over 2. Yeah, we can just take out the negative again to get to what they have. So that can be minus, that can be minus, that can be positive, and they'll can both become positive. And that is the answer given in the book. So yeah, we could have done it differently. We could have, instead of doing that, could have gone with minus e sine beta minus e sine minus alpha, and then you would see that that would, you take out the -1, and yeah, that would become minus that, and that would become positive there. So that's fine. Don't need to worry about that. Yeah, that's the answer. That's it worked out. Thank you very much. If you have any questions or you think I've made a mistake, let me know in the comments. Thank you. Bye-bye.